Okay, so before we start with intersection of graphs, I'd like to have a go at this question by yourself. So pause it now, and then I will go through it with you. So we're finding the coordinates of the points of intersection of the line y equals 2x minus 1 and the parabola y equals x squared minus 3x plus 5. So this is just building on from GCSE, a bit of a recap. So as soon as we see points of intersection, we need to be thinking about simultaneous equations. So because this equation is equal to y, and this equation is also equal to y, and we're finding the points of intersection, so therefore where the values of y are the same, we can simply put these equal to each other because I know y is going to take the same value. That's what we're looking for. So we have a quadratic equation here, and we know that a quadratic equation has to be equal to 0. So I'm going to take away, ignore that. I'm going to take away the 2x. So I've got minus 5x. I'm going to add the 1 plus 6. Now at this point, now your quadratic is equal to 0. We just need to solve it, so you can do that through quadratic formula, factorising, completing the square, or you can use the function on your calculator. Now I know that that factorises to x minus 3x take away 2 equals 0. So x can either be 3 or x can be 2. Now be careful at this point because a lot of people stop and think they've finished the question, but we need to go back and figure out our y value. So we need to substitute in our x's to figure out what y is. Now I've chosen the linear equation just because it's simpler, but it would work by using the quadratic equation. You could try both if you want to double check to see if your answer's right. Now again, one other thing to watch out for, it's asking for coordinates, not the values of x and y, but specifically coordinates. So you do have to write your answer as coordinates, so 3, 5 and 2, 3. So that's a skill that you're going to need for the section of work that we're doing next. So you're supporting learning targets. First one, I can link solving simultaneous equations and the intersection of graphs. And your second one, I can determine the number of intersections between a line and a curve. So that example that you've just done is for that learning target. So what I'd like to do now is to go to the book and have a go at questions 5 to 7. So remember, like we do in class normally, these sections of questions get harder as they go up. Generally, you both start with the blue questions, the blue numbered questions in the book. So have a go at 5 and 7, please. Make sure you're marking your answers using the answers in the back of the book. Can you also, just as a reminder, take a picture of it and upload your work to me so I can just check progress that we are making. So if you pause it now, have a go at that and then come back and we'll have a look at this second learning target. So looking at the number of intersections then with a line and a curve. So I'm going to find the set of values for k, for which the line with equation x plus y equals k intersects the curve with equation x squared minus 4x plus y squared plus 6y equals 12 at 2 distinct points. So we're looking at points of intersection, so already we should be thinking, I need to be looking at solving simultaneous equations. Whereas this time we're not actually finding the points of intersection, we're just going to try to work out what this value of k is. Now, when we're looking at, it specifically told us that it intersects at 2 distinct points. Now, they've given that information because it's key to this question. As soon as you see points of intersection with how many points of intersection, you need to be thinking of the discriminant, which you've covered already this year. So b squared minus 4ac. Now, as a recap, if there are 0 points of intersection, then the discriminant is equal to a negative number, so less than 0. If there is 1 point of intersection, the discriminant is equal to 0. And if there's more than 1 point of intersection, the discriminant is greater than 0. So in this question, we need to put it equal to 0. So this time I'm going to need to rearrange this equation to make it say y equals, to make y the subject. You could rearrange it to make x the subject. It'll give you different working out, but your final answers will still be the same. So if you want to rearrange it to make it say x equals k minus y, then do that and you'll find that you'll get the same final answers. But I'm going to stick with this. So wherever I've got y in my equation here, I'm going to substitute it with k minus x. Now we should recognise here, because we've got an x squared and a y squared, that this is actually an equation of a circle. So we're seeing where a line intersects with the circle. So x squared minus 4x plus k minus x all squared plus 6 lots of k minus x is equal to 12. So now we're just going to expand and simplify this. And remember, at any point that I'm going too fast, just pause it, give yourself time to catch up. Now we have got a quadratic equation here, so as again, we need to have the quadratic equation equal to 0. So I'm just going to rewrite it, taking away that 12. So all we're worried about really is this discriminant. So we just need to work out what the values of A, what's the value of B, and what's the value of C. So we need to do a bit of tidying up with this equation that we've got here. So I'm going to put all the coefficients of x squared together. So I've got an x squared and x squared. So 2x squared. So that's quite obvious that our value of A is 2. Now if we look at everything involving the x's, I've got 3 things there. So I've got minus 4x minus 6x. So that's minus 10x. And then we've got this minus 2kx here. So just be careful not to forget that. So I've simply taken x out as a factor here. So then I can see that my coefficient of the x's, so therefore the value of b is minus 10 minus 2k. And then the rest involved that doesn't have coefficient, any x squared or x's involved, it's going to be our value of c. So k squared plus 6k minus 12. I'm just going to put brackets around that. You don't need to, but for me, it just helps me see that that's going to be my whole value of c. Right, so I'm just going to add in a page now. So we'll just go back to the example. So now, if we're happy with that, go to these questions, page 71, and it's just questions 1, 2 and 3. And again, complete the work, take pictures, upload it, send it to me, then I can check the progress that we're making. With that working out, so I'll just rewrite where we got so far. So we had 2x squared plus minus 10 minus 2kx plus k squared plus 6k minus 12 equals 0. We have brackets around that. So again, A, B, C. So for our discriminant then, we need minus 10 minus 2k squared, that's b squared, minus 4 lots of 2, that's your 4a, and then c, k squared plus 6k minus 12 equals 0. So again, we need to expand and simplify this. So expanding your first bracket, 100 plus 40k plus 4k squared. I'm just going to write that as 8 because I know 4 times 2 is 8. So we're going to have minus, careful of that minus 8k squared minus 48k plus, negative times negative 96. It's going to be things like that that catch you out, if anything. I've realised I've just messed up throughout all of that because I've put equals 0 and we said that if it's got 2 distinct points, then it has to be greater than 0. Apologies for that. So I'm going to simplify it. So I have minus 4k squared, that's the k squared's dealt with, minus 8k plus 196 is greater than 0. I don't particularly like working with the coefficient of k squared or x squared, whichever it is, being negative, so I'm going to rewrite this, changing the signs, not forgetting to change your inequality around as well. So again, you can use quadratic formula, use your calculator, whichever you want to do to solve this. Once you have solved this, you'll find that k, your values of k would be negative 1 plus 5 root 2, just taking it from your calculator, negative 1 minus 5 root 2. Now, as this is a quadratic inequality that we're solving, we need to do a sketch. We must do sketches to show how we're solving this. If you just do it in your head, you will lose marks in your exam. So I'm going to do a quick sketch of the curve. So it's crossing here at negative 1, negative 5 root 2, and here negative 1 plus 5 root 2. Now we're looking for it less than 0 because we changed the signs around. So we're looking at this region here. So then we're going to have k is greater than this value, which is negative 1, negative 5 root 2. And k is less than this value, negative 1 plus 5 root 2. So this, answering the question, the set of values for k, this is the set of values for k. That is your answer. That is your question answered. So just be aware, are you looking for coordinates for points of intersection? Are you trying to find unknowns? And in this case, because it's an unknown, we're not finding that second value of anything because it's just a value of k that we're trying to work out.